Dear viewers, we'll be back from the break. We are progressing slowly by slowly. Now we have gone to number 4. Number 4 has changed the mode of the language. The language is not talking about real roots or what, but it's talking about solving the inequality. Since we are looking for range of values of a quadratic function, you never know, this might also result into a quadratic function. Let us go and see what is hidden in this setting of the examiner. What I need people to understand is how now to deal with such a question. Some people are going to cross multiply. Cross multiply is going to be wrong for an inequality, unless if you had equal signs, because this side is not equal to that. The left hand side is greater than the right hand side. So there is no way you can cross multiply here. That is wrong. It is wrong math. Totally wrong. I want people to note me on that. So what are you going to do? The correct procedure is to remain with a 0 on the right hand side and then bring all the unknowns on the left hand side. So we are going to lift the whole of the right hand side onto the left hand side, and it is going to change sign. So we shall come and say, Mr. Examiner, sir, this is our solution. So in our solution, we come and extract the question, that is x minus 1 over x minus 2 greater than x minus 2 over x plus 3. Then we cause a change, because math is all about causing a correct change. So we cause a change here. It will become x minus 1 over x minus 2 minus the whole of this fraction, x minus 2 over x plus 3. The right hand side has remained with 0. We have lifted this fraction onto the left hand side. So try to get the common denominator, not basically the LCM, but just the CM, a common denominator or common multiple. Common multiple is by multiplying the denominators. So when we multiply the denominators, this is what we are going to get. We are coming up with a common denominator, which is x minus 2. Use brackets to distinguish between those pairs. So the whole of this divided by the denominator here, x minus 2 will cancel. We shall remain with x minus 3. So we take it to the numerator. It finds x minus 1, so into x plus 3. Good. There is a minus sign here. We go ahead. The whole of this denominator divided through by x plus 3. So x plus 3 will go away. We remain with x minus 2. So we shall end up having x minus 2 here, x minus 2, which was originally there, and the x minus 2 we have carried after dividing our denominator by x plus 3. We remain with x minus 2. So our x minus 2 is there. So the whole of this is greater than 0. So that is how far we have gone. We can make this one clear by trying to enlarge the space here such that we have our inequality visible. So the whole expression is equal to that. We can go ahead to simplify. If we try to simplify this, you realize that x times x is x squared, x times 3x minus x, which is equal to 2x, then minus 3. You can go on simplifying like that in that format of arrangement. You also realize that this is the same as x minus 2 squared, x minus 2 squared. So let us try to simplify. So we shall have our fraction here, and it is going to be greater than 0, as we are going to see. So this has given us x squared, good, then minus 2x, then minus 3. Is that correct? Yes, because we said x times x, that is the same as x squared, which we have here. Then x times 3, it is 3x. Negative 1 times x, negative x, meaning that this is a positive, because we shall have a positive 3x minus x, which gives us a positive 2x. Then negative 1 times 3, we shall get a negative 3. Then this is the same as x minus 2 squared, which is a perfect square. a perfect square, which will bring up to a minus brackets, okay, x squared minus 4x, then plus 4. If you square x minus 2, you will get this. You will come up with that. Very interesting. So denominator has not changed. It's the same as x minus 2, then into x plus 3. The whole of this is greater than 0. There is nothing which has changed the greater than sign or the inequality symbol. So in this kind of arrangement, if you try to open the brackets here, we shall get a negative x squared, which will cross out with that x squared. Then this negative will affect this to get a positive 4x, which will now come to a 2x to produce a 6x. So this implies that we are getting a 6x, Mr. Examiner sir. Then negative 3 is there. Then negative times a 4, that is also a negative 4. Compare it with negative 3, they will produce a negative 7. So minus 7, good. So the whole of this over our denominator, which is x minus 2 into x plus 3, good. So we can equate this, not equating, but introducing the greater than sign, which is there. So from here we can get the critical values. So dear viewers, what are the critical values of this function? Because now once it reaches here in the factorized format, the next step is to get a contingency table. What are the critical values? We are going to observe that if we equate the numerator to 0, we shall get 6x minus 7 is equal to 0. X will be 7 over 6. That is a critical value. If we equate the numerator to 0, we shall produce a positive 2, and then we shall produce a negative 3. So we start with the smallest critical value. So this is in terms of x. So we are going to talk about critical values in form of x. So we come and say that the critical values of x are, we start with the negative, okay, negative 3. We go to the smallest, that is 7. The next smallest, that is 7 over 6, I think, is the next smallest, because it will produce 1 point something. So that is 7 over 6. And then finally, we shall have a 2. So we have already drawn our contingency table in advance. We don't want to take a lot of time. So we come and rearrange these values. So what you will have here are the values of x. Then up, you have the first region. These are the regions. You will have a 6x minus 7. Then you have x minus 2. Then you have x plus 3 as a region. And then you have the whole denominator as x minus 2 into x plus 3. Yes, it is going to disturb you. You can bring it. You can also give it a region on its own. And then finally, we have the function. If the function is too big, the function is this. You can call it y if you want. But it's not very big. We can put it here. That is a 6x minus 7 over x minus 2 into x plus 3. So the reason why this level is called A level, it is advanced. We expect your reasoning also to advance. Okay? So this is a way of solving inequalities. We are applying the method of range of values of a function. Because we are seeing a quadratic function coming in down here. So it is still under quadratic function. But it is a hidden question. Not very, very easy for everybody to understand it. It is quite hidden. So you need to go and interpret it with a lot of care. So in this region, we have, we can start with what to put here with the smallest critical value, which was negative 3. So when x is less than negative 3, then from this smallest to the corresponding one in that ascending order. So negative 3 is less or equal to x, less or equal to 7 over 6. Then 7 over 6 less or equal to x, less or equal to another critical value, and then we also check beyond the greater critical value. That for x greater than 2, what will be the value? That is very interesting. So we come and substitute. This is going to give us a lot of, it's going to take a lot of time. So I'm coming back when you have substituted. So try to substitute. It's just a matter of substitution. Get a value which is less than -3, substitute here and see what you get. Get values here and see what you get. So on and so forth. I want the contingency table filled. Immediately after the break, you are going to check your answers, whether you are correct or wrong. Stay tuned. We'll be back from the break. Yes, hope you have got the correct answers. The teacher has also been working out. He has also got his answers. Hope they are going to be the same with yours. So, this is what I have. For the first column, I have negative, 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 positive. So, how do I get the negative here for the whole function? I considered the numerator, which is 6x minus 7, and then the denominator. When you divide a negative by a positive, you get a negative. That's how I've got it. Then here I got a negative, negative, positive, negative. So how do I get the positive answer here? I consider this negative for the numerator, 6x minus 7, then divide through by the product, which is a denominator. This is the product, yes, in the fourth row, and it also gave me negative. So negative, negative, it gave me a positive. So the same applies to this second last column. I have a positive, negative, negative. And how do I come up with a negative? It is a positive divided by negative, which gives me a negative. So the way I categorize these regions, it was making the final answer to be got in a simpler way. Reason being, I got the denominator, and then the numerator was also got. So denominator catered for, numerator catered for. So this quotient can be obtained very, very well. So lastly, for x greater than 2, I'm getting only positive values, and their quotient or division will bring out a positive value. So what do we need in this kind of expression? Look at the final simplified expression here, which gave us the critical values. We need the expression to be greater than 0. Anything which is greater than 0 is a positive number. It is a positive number. So we pick those positive regions. We shall take the second region and then the last region. So we can get some space here. If you have not copied this, pause at this point and then try to copy. Or if you are watching me live, take a screenshot. You have enough visible space. You can take a screenshot. So let us go and see, how do we conclude? We come and say that therefore, Mr. Examiner Sir, this is how we conclude, that therefore the first region to take is -3 for that inequality. -3 is less than x, less than 7/6, and then we also have x is greater than 2 are the required solutions. Solutions. So this is an advanced level. We are no longer solving inequalities wrongly the way we are doing in the junior level, in the ordinary level. So this is advanced. So you need to advance your reasoning. So that's what we have. Oh, very interesting. Now, immediately after a break, as if these examples are not enough, I'm going to add you another example, and that is example 5. Stay tuned. Yes, dear viewers, we'll be back from the break. We are still progressing slowly but surely. It is now example 5. Oh, example 5 is a little bit different from the examples we've been encountering rather. So when you look at example 5, we are given y as a quotient 3 minus 2x over 4 plus x squared. And we are told to find the range of possible values of y for real x. This time around we are not finding the range of values of x. What does this imply? Oh my dear, very twisted. So let us go and see the approach here. So if now we need the range of values of y for real x, which means our factorized format, where we are going to pick the critical values, that expression or that equation should be in form of y. So let us go and form a quadratic expression or a quadratic function in x, such that y now remains, and then we take it to the contingency table. So let us go and see in our solution. We shall come and say, Mr. Examiner, sir, this is our solution. You have given us y is equal to 3 minus 2x all over a 4 plus x squared. So what we are going to do here, let us try to cross multiply such that we get a linear equation if possible without these quotients. So in this kind of arrangement, we shall now have a y into 4 plus x squared, which is equivalent to 3 minus 2x. So let us try to open brackets and rearrange in form of a quadratic equation. You realize that 4 times y times 4, that is 4y, y times x squared, that is x squared y, or y x squared. Then we bring this minus 2x, so minus 2x. Then we bring a 3 and then a 4y. So plus 4y minus 3 is equal to 0. So this is in the form of a quadratic equation. What makes it a quadratic equation? Come and see. If we compare from ax squared plus bx plus c is equal to 0, you realize that the quadratic coefficient is y, the linear coefficient is negative 2, and then the constant or the quadratic constant is 4y minus 3. So we can go and pick the discrete. The examiner is talking of real x. Okay, and for x to be real, it can either have repeated roots, this equation can have repeated roots, or it can have what we call two distinct roots. So we are going to see an inequality coming in this kind of arrangement. So the inequality which is coming in is that inequality will equal or greater than. So for real x, our b squared minus 4ac is greater or equal to 0. So we come and pick the values of b, a, and then c. So the value of b we have already seen, it is negative 2. So this implies that, Mr. Examiner, sir, negative 2 squared minus 4 into the value of a, which is y. Then into the value of c, which is a whole 4y minus 3, where x is no longer visible, but in actual sense it is there to the power 0, which power 0 gives you 1. So we have a 4y minus 3. This is greater or equal to 0. So when we try to simplify this, I'm seeing a 4 coming in minus a 16y squared, and then plus a 12y. How have I done it? I'm seeing a negative 4y times 4y to give me a 16y squared, which is negative. Then I'm also seeing a negative 4y times negative 3. It gives me a positive 12 and then the y. So we can rearrange this to get a very nice expression, 0, in that format of arrangement. So when we rearrange this, we can start with the maximum power. I'm seeing it is bringing a quadratic function. But we can divide through by negative, and then the sign is going to change, such that we can start with a positive 16y squared, then minus 12y, and then plus 4. Is it plus? It is a minus 4. Where is my duster? Okay, so it is a minus 4. However, we can still simplify. Divide through by 4. I'm saying we can divide through by 4. Let us first finish here and then divide through by 4. So when we divide this side, the left-hand side of our inequality, the sign of the inequality is going to change because we have divided the coefficients of the unknown. So the sign changes now to a less of, okay, a less than sign in that kind of range. So divide through by 4. I'm seeing this is going to give us now, okay, this is going to become a 4, this is going to become a 3, and this is going to become a 1. So since we don't have space, we can use this equation. So we don't have space. We are dividing through by 4. We had a 4 here, which is becoming 1 now when we divide through by 4. We had a 12 here, which is becoming a 3 when we divide through by 4. We had a 16 divided through by 4, which becomes now a 4. So we have 4y squared minus 3y minus 1. So we can go and factorize out this. Yes, this is a quadratic function. It can be factorized very, very well. So what do you get when you factorize this? We have a product of negative 4y squared, and we need a sum of negative 3. So those are factors of 4, numbers which you multiply and get 4. And that is 1 and 4. Then we have also 2, 2. So to get a negative 3, it means the larger factor should be negative. So you will have a negative 4 and then a 1 and then a 1. Okay. So when you add them, you get a negative 3. When you multiply them, you get a negative 4. So it's just a matter of attaching the unknown, the unknown. So in that kind of arrangement, we can go and then see what we get. So some side work to see how to factorize this, because it's not a linear expression or a quadratic linear expression. So what are we going to do? We are going to say 4y, this is part of side work, we need a factorized form, we put it here. So minus 4y, then plus y. We are now replacing the negative 3y by the two factors. So minus 1. Okay, we are just factorizing. So this is going to be put each in bracket, factorize out. What is common here is 4y into y minus 1. When it goes back, we shall go to 4y squared, and here we shall go to a 4y. Then here we have a y minus 1. The 1 is out. So we factorize out y minus 1, then into 4y plus 1. So this is the factorized format. So we don't need this. We can just bring this side work. We put it here. That when we factorize this, we come to a y minus 1, Mr. Examiner, sir, into a 4y plus 1. This is less or equal to z, less or equal to 0. So we can remove this. We don't need this. Okay, it was just our side work, trying to make everything simplified. So now we can go and get the critical values of y. So tell the examiner that critical values of y are. So we get the critical values by assuming each of these factorized brackets equivalent to 0. So if it is equivalent to 0, the value of y you get becomes the critical value. So when we equate y minus 1 is equal to 0, we shall get y as 1, which is a positive. And when we equate 4y plus 1 to 0, we shall get y as a negative a quarter. So we start with a smallest. So negative a quarter and positive 1. Those are the already drawn contingency table. So contingency table is already here. We have got our regions. We can get these are the different regions. Then we can go and based on the critical values. We start with the smallest critical value. So it is a negative a quarter. Oh, it is y less than negative a quarter. We are no longer speaking in terms of x. It is now in terms of y. So y less than negative a quarter. So we want to check on the left hand side such that we see, are there some values which will make this particular expression to give real values of x, to give real values of x. Okay, so then between the smallest and then the corresponding critical value, that is 1, and then beyond the greatest, that is y greater than 1. Can we get the required range of values? So let us go and see. On the left of negative a quarter, that is something which is less than negative a quarter, we can pick negative 1. So negative 1, put it here, it will give you a negative, bring it here, it will give you a negative, get the product, it will be a positive. So come here, between negative a quarter and 1, we can pick a 0. 0, put it here to give you a negative. If you put a 0 here, to give you a positive. Okay, we are just substituting for value of y. And then we see whether the resultant is positive or negative. So when you try to get the product here, the product is going to be a negative. Okay, so anything which is greater than 1, we can pick a 2. So bring a 2 here, it will give you a positive. Okay, bring it as a value of y here, it also give you a positive. And then the product of these two will also be a positive. So it is very, very clear that according to the simplified format of our factorized expression, that we need it to be less than 0, and anything which is less than 0 is on the left of the number line, and that is a negative value. So where is the negative product? The negative product has only been obtained between this range of values, negative a quarter and then 1. So we can go and quantitatively conclude that therefore Mr. Examiner Sir, the required range, these are not ranges, but it is a range of values. The required range of values is negative a quarter less, okay? We are now going to bring in an equal sign because it was for real x. Can bring a repeated root, and I think a repeated root will be at these values. Okay, so less or equal to y, less or equal to positive 1. So that is the required range of value. So dear viewers, hope this is enough for you. Oh, we may have only one example, that is example 6. Then after example 6, I'll give you your trial number. So watch the numbers, all the examples we have so far done, watch them if you have been recording, go through them, gain the confidence, and then prepare for your numbers when your turn comes. So immediately after break, I'm coming back for example 6, and it is our last example. Don't go away, stay tuned.